14D, and it was the first day. Hey, Neil's in the front. Wait, that's not a student or TA? He was nice, no hardened germ. He says with enough work, we could be a Jedi master. Well, we jump right in, and what do we learn? Functional groups were a concern. And SN2, a nucleophile attacks.
But don't forget, it's from the back. Remember inversion of stereochemistry. And that's all, this class is easy.
But after SN2, SN1 was here. A different form of substitution. We felt like death was near.
No time to die, elimination had to be learned. With the right reactions, a good grade can be earned. Now there are 4 reactions to choose from. What would we do? Tertiary carbon met SN1, a strong base E2. The first 2 palm sets were up, not so bad. It seemed like we were actually understanding OChem.
And we were glad.
After the first midterm, we were on cloud 9. The exam was easy, and we all did fine. Then Neil decided he would change things around. Alcohol synthesis brought us back to the ground. Who knew they could be made in so many ways? From aldehydes to ketones. You'd be amazed. Lithium, aluminum, hydride, and NaBH4. Who cares? Alcohol synthesis is kind of a bore. Just kidding, we love chem. No need to hate. Use the hydrogen and NaH to depronate. Next up, Neil whipped out some reactions with redox. He said, don't worry, guys.
This stuff really rocks. For oxidation, use PCC or chromium. 2 choices, why can't there just be one? Grignard reagents, CH3 minus, organometallics plus OH, what a crime that is. A 3-membered ring, oh you mean an epoxide? Acidic or basic, make sure to attack the right side. We thought it was done, but that was just a fraction. Not just 1, but 11 new alkene reactions. Stereochem, is it anti or sin? Couldn't be happier when Na was written. Markovnikov's rule tells us where H is placed. Memorize the year 1870, what a waste. Ozonolysis breaking alkenes, what a trip.
Thank God that was a mechanism we could skip.
Alkenes weren't so bad, alkynes were weird. When Neil taught us tolerization, no one cheered. Enols were unstable, don't forget. Markovnikov and redox weren't done just yet. They were back to haunt us, paired with new solutions. Why didn't we just quit after substitution?
Then we learned about Neil's father-in-law's vape reaction. He talks about it constantly to Neil's dissatisfaction. Deals alter. A dine and dienophile convene. Heat is needed to make them into a cyclohexene. Dienes are electron donating, electron rich. In case you forgot, here's a list. Alkyl and alkoxy, those are worthwhile, but these wouldn't make a good dienophile. Dienophiles are electron withdrawing, electron poor. CN and C are 3, plus 1 more. Our second exam is in 4 days. What's the deal? But Neil said there's more. Is he for real? Electrophilic aromatic substitution, he exclaimed, but we all just turned to our neighbors and complained. It's not that bad, he said. Come on, guys. We thought he was nice. Was it just a disguise? But it turns out he was right. Only 5 reactions. No need to put up a fight.
But it didn't stop there. It couldn't be that easy. Now there were substituted benzenes, which made us all queasy. The final's drawing near. When will Neil stop? After every lecture, our brains feel like they're gonna pop. We tried doing synthesis problems, but we kept getting stuck. With the help from our ninjas, maybe we'll have more luck. We're studying really hard and doing our best. Just 1 more week and then we can rest. We hope you enjoyed our little show. Now give us an A so we can go.